Student, I'm going to start this video from the last slide which has been described in the last video. uh, the topic, that is spiral SDLC model, or you can say spiral system development life cycle model. Before this we have discussed about waterfall model and V-shaped waterfall model. Here you can see actually whatever we have learned till now about waterfall model and uh, V-shaped waterfall model. Here is just that risk analysis and prototyping to the waterfall model is added. But here what is more significant is that the things will be go on in a spiral way. Each cycle involves the same sequence of steps as the waterfall process model. So here you can see every cycle will follow same like waterfall model, but it will go on and on. That cycle will iterated, reiterated again and again until everything satisfied. And also what has been added in this, that is risk analysis and prototyping, that has been added in this spiral model. But every cycle is same like waterfall model. Okay, so this is the basic overview of the spiral model. You can see, suppose initially you start with requirement plan or review of the system life cycle plan, then you try to go for risk analysis, then you go for prototype 1, that is prototype 1, then you try to simulate those things, then you go for concept operation, means whatever result you get after prototype 1, then you go for development plan, then you go for, again this is review phase. Okay, then again risk analysis, again prototype 2, and again simulation, and again software requirements, requirement validation, development plan, and again risk analysis. So in that way these things will go on and on. But you can see here one complete cycle, or this is one complete cycle of here you can see first start with requirement analysis, then go for, in some stages go for design, or you can say requirement about development, requirement validation, development plan, then again go for design, then again go for integration, testing, design. All those things are like waterfall model, the name you can see here. But point is that at every phases there is risk analysis, there is prototype modeling, and depending upon those analysis, and try to simulate those prototype to gather more information about the software, about the design. So in that way it is more or like the waterfall model, but it goes on like this in a spiral way. It repeats the process again and again until you meet the main version of the system. So what is that spiral quadrant here? um, Determined objectives, alternatives, and constraints. So there are, this is one quadrant, this is second, or we can say this is one quadrant, second, or 1 2 3 4. So there are 4 quadrants of this diagram. So what are these? Determine objectives, alternatives, and constraints. So what is objective? Objective is that we need to find the functionality, performance, hardware software interface, critical success factors. Okay, then alternatives: build, reuse, buy, subcontract, etc. Constraints are like cost, schedule, interface, etc. So another quadrant is this one. So this is one quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. Okay, so first quadrant is about evaluate, alternatives, identify. This is determine objectives, alternatives, and constraint. So you can think like this one: evaluate, alternative, identify, resolve risk. This is the first quadrant. Second one is develop, verify, next level product, or you can say evaluate, alternatives, identify, and resolve risk. Here you can see First one is determine objectives, alternatives, constraint. Evaluate item arrives, item alternatives or identify resolve risks. Second one is, third one is develop, verify next level product, and then again plan next phase. So it is starts from this phase 1, 2, this is 1, this is 2, this is 3, this is 4. So here you can see in the slide also you can see here, this is 1, this is 2, this is about study the alternatives relative to the objective and constraints, identify risk, lack of experience, new technology, tight schedule, poor processes, etc. Those risks need to be identified out. Resolve risk, evaluate if money could be lost by continuing system development. So you need to try out those analysis, risk analysis in this quadrant. You need to find out any alternatives or evaluate the alternatives, identify those alternatives and resolve the risk. Spiral quadrant, another quadrant, that is develop next level product. So in this quadrant actually main work happens, that is like create a design, review the design, develop a code, inspect the code or test the product. So this is another quadrant. Like here you can see in this phase, all in this phase you can see the testing happens, or you can say design happens. Okay, here you can see create a design, then you review the design, then you develop the code, then you inspect the code, then again test the product. So this happens in that quadrant. In the fourth quadrant, so typically activities are like plan next phase, develop project plan, develop configuration management plan, develop a test plan, and develop a installation plan. So this type of way, in this way we can divide the whole spiral model in 4 quadrant. But working nature or things will go on like other models. Provides early indication. What are the strength actually? Spiral model provides early indication of insurmountable risk without much cost. So every time whenever you go for the risk analysis, you can decide or you can find out the major risk or the risk due to which you might lose lots of money. So that is why it provides an early indication of insurmountable risk. Users see the system early because of rapid prototyping tools. So actually here you can see initially this prototype 2, at every phases they try to build this prototype. So they try to go for a rapid prototyping tools, use repeated prototyping tools, and due to which they can see the whole system or snaps or the glimpse of the whole system initially. And that is why it is very useful for the designer also coder also developer also, to design the things as they get to know a bit about or the whole scenery as a glimpse about the main design or main information system. And also it is critical high risk functions are developed first. So initially you can design the or you can develop the critical high risk functions as you know all the things how they are going to happen, because at every phase you are trying to understand through the prototype development using rapid prototyping tools. The design does not have to be perfect. The design must not be or may not be perfect initially, but ultimately at doing every iteration it's going to be perfect anyway. Users can be closely tied to all life cycle steps. So any users can be closely tied to all life cycle steps. Yearly and frequent feedback from users might be collected for the development of your information system that is going to be built using spiral model. And because of the users involved in any or every stages or every phases of the life cycle, because of this reason you can collect those early and frequent feedback from the users. And cumulative cost assessed frequently. So because as this is a spiral model, you can iterate the process again and again, but at some point of time you can think like that the cost will be more after this step, so you can stop there. and that is why a cumulative cost assess is done frequently. So because that can be done because you are doing the job periodically and doing minimal work at every iteration to gain to achieve the larger task. Spiral model weakness. What is the weakness? Time spent for evaluating risk too large for small or low risk project. So here you can see that in this model also, here you can see that a lot of time is spent on doing the risk analysis and prototyping building. But if a project has low risk or small risk projects, then the time spent for evaluating risk will be too large for such kind of projects, and time spent for planning, resetting objectives, doing risk analysis and prototyping may be excessive. The model is complex. Obviously that the model is complex. Risk assessment expertise is required, so an expertise will be required to understand or assess the risk. Spiral may continue indefinitely. Obviously, this type of model might continue indefinitely. Developers must be reassigned during non-development phase activities. Oh, yes, sometimes those developers, like here you can see, this is only the developing phase. So sometimes what will happen like that, the developer might be or might need to be reassigned in other phases also. May be hard to define objective verifiable milestones that indicates readiness to proceed through the next iterations. Sometimes it may be hard to define the objectives or the milestones, so that so that those milestones or objectives can define the project's track or status, so which might be hard in this kind of model. But when to use the spiral model? When creation of a prototype is appropriate, when you need to obviously create a prototype, then you can go for a spiral model, because doing that way only you have to anyway, if you go for prototyping model, then you have to reiterate back, because prototype is not the on final ultimate version of your information system. You need to build the whole system. So initial prototyping building is might be a one phase or one iteration, then you need to go for again one iteration to build the whole project or whole information system. So whenever you need to develop a prototyping model, you can go for a spiral model. When cost and risk evaluation is important, sometimes for some project cost and risk evaluation is very important. In that case you can go for spiral model, because it will obviously provide a very good scope to understand or analyze this cost and risk. For medium to high risk projects, we can use this type of um, this type of life cycle model. Long-term project commitment unwise because of potential changes to economic priorities. Users are unsure of their needs. When users are unsure of their needs, then you can go for spiral model. And sometimes when the requirements are complex, then also you can go for spiral model. Suppose you want to build a new product, completely new product line, then also, because if you don't know what is going to happen after some time, because the scenario of the business might changes, so you might want to develop a version initially, then you might go for updating those version again and again. So that might be iterative process. So in that case also you might opt spiral model. Significant changes are expected, like research and exploration. So when some significant changes are expected upon a existing one also, then existing one information system also, then you can also go for spiral model. So next one is incremental SDLC model. So we have discussed till now is waterfall model, V-shape waterfall model, spiral model, and last one is incremental SDLC model. So here you can see you need to construct a partial implementation of a total system. So initially what you need to do in this type of model, that is you need to construct a partial implementation of a total system, then slowly add increased functionality. Now you have to add increased functionality slowly. The incremental model prioritizes requirements of the system and then implements them in groups. So incremental model actually it provides the preferences, or you can say prioritize requirements. So as per the prioritized requirements or preferences of the system, they try to group the features. And they try to think about what features will going to be done in the next phase, or what will not be doing in the next phase. That type of preferences is given. So according to that, the work will go on. The incremental model prioritizes requirements of the system and then implements them in groups. Each subsequent release of the system adds function to the previous release. Its subsequent release of the system adds functions to the previous release until all design functionality has been implemented. So for every release, they try to add new functionality until and unless they completely design the whole system. So they try to go in a subsequent manner. So in its subsequent, they release group of features, and then they try to add more features in next subsequent phases, and they will go on like this until and unless they meet all the functionality and that has been implemented completely. So in that way, that is why this can be called as an incremental SDLC model, because we will incrementally update the system by starting the system from the scratch as a partial implementation model, and in that way we'll try to increment the whole system one by one, step by step, and we'll try to complete the thing finally by installing or by providing or by releasing the significant or necessary functionality. So what are the strengths of an incremental model? We can develop high risk or measure function first. Obviously, initially when you design the partial system, then you can develop in that phase directly. You can go for the high risk or measure function first, and then each release delivers an operational product. Suppose suppose for an example, if you want to develop a Microsoft Office like suite, then suppose you initially deliver a product Microsoft Word, then obviously in the next product you are going to develop a Microsoft Excel sheet. So in the next one another measure preparation. So in that way, in each release, if you are going to deliver an operational or measure product, then you can go for incremental model. Customer can respond to each bill. So for each version or for each type of product that you are going to develop for the entire information system, customer can give you adequate amount of information or feedback for every release. So in that way you can update or you can incorporate those ideas or feedbacks to build a better software or build a better system in the next release. Use divide and conquer so that you can break down the task. The tasks need to be completed in a single phase or in a single release, and you can do that breakdown of tasks using the divide and conquer technique. You try to divide the task in subtasks and try to solve the subtasks first or easy tasks first, then you try to merge them down to solve the main problem. So lowers initial delivery cost. So obviously in the initial stage, as it is a partial development of the system, obviously the initial delivery cost will be lower and initial product delivery will be faster, and customer get importance functionality early. So obviously customer will get the important functionality early, and risk of changing requirements is reduced. So in that way, sense of changing the requirements or risk of changing the requirements will be reduced also. But what are the weakness? It requires group planning and design, requires early definition of a complete and fully functional system to allow for the definition of increments. So you can see that it requires good planning and design, requires early definition of a complete fully functional system to allow for the definition of increments, Well-defined module interfaces are required because the module has to be very well connected, because one module will be released after one module, then both module need to work out together. And as you are going to work both module in different phases, so those module need to be very good, need to have a very good interface, so that they can be communicated or they can be interrelated or integrated. So without that, it will be very tough to work upon the whole project. Total cost of the complete system is not lower. Obviously, as you are going to, as though you are going to develop a phase by phase manner, but the whole cost, whole project, whole information system might cost bigger or higher. So when to use the incremental model? Risk, funding schedule, program complexity, or need for early relations of benefits. So if you have this kind of situation, like when you need to realize the early benefits, then you can go for incremental model. When you need to understand the risk, funding schedule, program complexity, or need for early realization of benefits, then you can go for incremental model. Or also, most of the requirements are known upfront. Suppose you know all the requirements initially upfront, but are expected to evolve over time, but might be evolve over time. In that scenario also, incremental model will work. And need to get basic and functionality to the market early. Suppose you want to understand the market where you are going to throw your project, you need to understand, you want to understand the market, then you can go with the incremental model, so that you can understand the market with that initial partial system that you have developed in the initial stage, through which you can understand the users feedback, through which you can understand the market also. So in that type of scenario, we can go for incremental model. On projects which have lengthy development schedule, suppose some projects might have a lengthy development schedule, then you might divide it in sub phases or sub releases, so that uh, you can achieve that lengthy development in a well good manner without having any boredom. On a project with new technology, suppose you are going to develop a project with new technology, or the technology might be changing very fast according to your project, then you might go with a sub release or sub phase system or part by part release, so that you can attain the goal of your main project. So these are the models we have discussed till now. First one is waterfall model, second is V-shaped waterfall model, third one is spiral model, fourth one is incremental model. In the literature also, in the book also, you might find these ones, and also there might exist more of these types, or people might develop their own type of model also to suit their business. So we can go through them in literature also, in the book also. Please try to go through this whichever we have discussed in these videos as for your course only, but for your knowledge you can go for others also, and try to understand these topics is very important, because whenever you are going to develop any project, you need to go through like this to build a better software or better information system. So that's all about in this video. We'll try to start a new topic in the incoming video, in the next video. Thank you.